There we go. Sorry. I always forget.
Nobu already
Yeah,
answered. Yeah.
Firstly, I apologize that I have not prepared any materials for this session,
Don't
but
worry.
all the information about our 40-meter telescope is summarized in our webpage. So I try to show you some information related to the L band. Firstly, this shows the specification of telescope, 40-meter diameter and azimuth, and so maybe this is too small. If
1.8 gigahertz. That's great.
if asked, I will try to answer your question as much as possible. But firstly, let me briefly introduce. Optics. We have primary and Nasmith focuses, and L band is put at the prime focus. And latitude is 90 degrees. That's why we can observe all part of the sky. This is very good advantage of us. We can collaborate with many telescopes in the world. That's why maybe Busaba suggested this session discussing collaborations among us. And we have now L band and K band receivers. K band is used for commissioning holography activity, and L band is from 1 to 1.8 gigahertz, dual linear polarizations, and I'm not. Okay, let me show you one more slide. Just a moment. This is L band receiver and developed by Max Planck Institute for Radio Astronomy in Germany. And this is the diagram. We can see dual linear polarization signal paths, X pole and Y pole, I believe. And this receiver is pretty nice. The TRX is below 10 kilo along 1 to 1.8 gigahertz in H and polarizations. Sorry. Typically our system noise temperature at L band is around 20 Kelvin, or it slightly changed depending on the RFI environment, but I can say that it's very nice receiver. And one information about our backend system is to use the universal software backend developed by also Max Planck. So this backend allows us to use many observation modes. For example, we have opened only one spectroscopy mode, but we have a lot of other items. Full stocks backend. Sorry, this is very small. And this is under commissioning, and also Pulsar backend, and also VLBI backend. So if our GPU resources are enough, ideally we can operate different observation modes simultaneously. For example, single dish spectroscopy, full stocks, pulsar VLBI, or etc. Of course, but it depends on the GPU capability of our backend system. So this is, I believe, basic information about telescope. But if you need more information, I will try to answer. And I hope Pusawa will lead this session. Of course, I will also join to discuss with many of you.
Can I ask really quick, what's the resolution of the channels?
It's very good question.
Very good. Okay, good.
To be honest, now the best frequency resolution is 2 kilohertz, but now it's due to the limitation of backend system. Now we have to record all frequency, meaning that we have to record 1 to 1.8 gigahertz, but now we are developing to install zoom in mode. So in the near future, the frequency resolution should be improved, but at this moment, we can provide the best frequency resolution of only 2 kilohertz.
Wow, very nice. Thank you.
So that's just a processing constraint at the moment?
I have not fully understood this point, but yeah, now software team is trying to update this portion. Yeah, if bank, if you know it, yeah, could you comment? But maybe
Yeah.
this our microphone is muting.
Ben can give some information or can
Yeah.
you
Well, I mean, you can go ahead first. I was just gonna
Yeah.
update on the whole like backend situation, just like
Yeah.
very quickly.
Maybe I can just give the quick overview that how we want to we plan to develop TNRT from the beginning. Yeah, I think we organized the brainstorming like from 2016, and by inviting all astronomer and engineer around the world, including Tasso from CSIRO. We had MPIFR, of course. So therefore, with such the contribution from global expert, yeah, we decided to go for the frontier of the receiver technology by from both the front end. We want ideally all of our receiver will be digitized, and with the back end system, we go for the EDD or the universal back in system rather than hardware. So therefore, all the capability can be upgraded, by, of course, they're limited in terms of our manpower, but however, we collaborate tightly with MPIFR, and we also see a good example from Australia, the 18F, how PATHS and the SKA technology, for example. So therefore, I think I would say that all this capability will be, slowly improved, but of course depend on the limited manpower at TNRT at the moment. Yeah.
Yeah, I mean, I was just gonna say that, mostly, really, it's all about manpower at the moment. Like we just don't have enough people working on the back end right now, because like we've got a few things happening simultaneously. We have got the L band cycle 1 observations, we've got the K band commissioning, but also there's been like a recent upgrade to the EDD as well. So we've been like checking that against the old version, and that's been kind of like a really tough job on the software team, to be completely honest. So so for the moment, I can say that okay, with the L-band, we have some some confidence that we can actually do good science like at the moment. But apart from that, unfortunately, I think we'll need some more time to like fine tune some stuff. Yeah.
It's great though. If you can sort of get things started and then allow some of those improvements to come in later, that's good. It gives you the momentum, I imagine. It's good.
I see that in the, oh, sorry.
Yeah. Sorry. Say, yeah.
Oh,
Michael, yeah.
I noticed the deadline for the proposals is passed. So is the next call is when?
Around, it's not yet fixed, but maybe
Should be
around September, or October. Yeah.
Okay.
So I would say at this stage, certainly the L-band receiver is available and, very much open for the good project. For example, I had discussed with Anita before, with the parks, her work in parks monitoring of the OH, the Southern Sky sources, and perhaps there's some good candidate that we want more time, or show good variability that we would like to concentrate on. I think a few of sources that would be enough to test with TNRT as well, and we can compare with the previous observation by parks, or we even can do the simultaneous observation, for example. Yeah, certainly flux calibration, it will be quite I would say that the flux calibration is really something that we should compare, because for TNRT, we need also to confirm, what is the uncertainty of our, flux measurement, for example. Yeah. So that will be, some project that can be, can be done already. Yeah. And if Nobuyuki could show some timeline of our observation plan. I think there's a VLBI or other receiver in one of your presentation.
Okay.
Yeah, so we plan for the single dish, certainly for L band is available. Yeah. And the K band will be coming up hopefully the end of this year, or certainly, probably in full function or cherries next year. And hopefully also with the full stop backend. Yeah, full stop. Yeah, I can give you more information of why full stop is very important for OH. And of course, by the end of next year, VLBI, will more probably should be available, together with the other CXKU band receiver as well. And that's already plenty, plenty of time and how say that, and instrument for OH measure observation itself. Yeah. And can I before we discuss, because I missed Gordon and Anita's session, and I had chance to go through the YouTube, and then I would like to, if you allow, I would like to add the discussion on that, follow up the discussion that, between single dish observation of this Zeeman pair and why we need the VLBI. So can I share my screen? Yeah.
Yes, please do.
Yeah. So I go back. A moment. So to share. So you can see it, right? Yeah. So I go back to the very old work. Can you see me?
Oh, here
Can
it
you
is.
see my screen?
Yeah.
Mhm.
Yes, that's
Yeah.
good now.
Yep. So sometimes it's nice that the thesis that you done opposite to Gordon, that he doesn't use his thesis anymore. I'm happy that my the topic that I done on my thesis, on the Zeeman measurement with OH measure, it's still there, and it's still a question, and it's still difficult. Yeah. For example, we were talking, let me give you a little bit of the background. So this is a part of my thesis. I think I have to close this one, right? Yeah. So when we're talking about the the Zeeman pair, so you might see that these are different transition, and when they are in the magnetic field, they split into different energy level. And Malcolm can also correct me if I'm wrong. And what you would expect to see in the spectral line, of course, is all depend on the direction of the magnetic field. If the magnetic field is certainly towards you, you will see only the split of these two components of the Zeeman pair, which is sigma, right? So you have sigma plus and sigma minus. If it's a real pair, you should be able to detect these two lines in different frequency. And this is so the normal VLSR of the gas should be in the middle, and there's an increase and decrease of the frequency show as a splitting. And if you can do multi or simultaneous, you would say almost simultaneous observation of these 1665 and 1667, and if you can identify the same spot, you would see the different splitting, which should give you the same magnetic field because it's the same molecule but different transition. And of course, in the 1720, if you can, because often in the star forming region, we can detect those three lines together. Yeah, most of the sources, I think, is different in the late type star. However, in 1720, the splitting is more complex. When Gordon talked about that yesterday, that I think the splitting coefficient has been corrected. However, when you observe, you actually, you know, you will be observing these three together, or maybe only one, right? So all this has to be identified by position. You know, otherwise I think it's everywhere. You don't know which one is which. You might mistakenly, for example, you might see in 1720, you might see sigma +1 and sigma -2, and you assume this is a pair because somehow you don't see this one, which I think Malcolm can add to that because of amplification or because of other effect in Maser theory. So you might, you know, calculate the wrong magnetic field. However, if you can observe, you know, those three lines together and at the same time and at the same source, and you can confirm with interferometric or VLBI, you will be able to really confirm or can say that it's real Zeeman pair. For example, in this case, apparently the only very rare that we can observe the pi and the sigma plus and minus in 1665. And then you can, when you do the full polarization, this is the full polarization observation of the E. Merlin back in, I think, 20 years ago. However, with full polarization capability, you'll be able to study, you know, the polarization intensity, the Stokes IQ UV, and also you can see the reverse. This is particular spot resolved by the Merlin at that time. And importantly, you should be able to identify the fraction of the linear polarization and circular polarization. For example, the pi itself should exhibit 100% linear polarization. That at that time can be detected so that we confirm it's pi. However, if it's alone, we can't say that it's pi. Well, you probably can say if it's 100% linear polarization. And also with full polarization, you can detect, you know, polarization position angle, because if you have those two sigma should have the same position angle, which is perpendicular to the pi component. So this is the only, I would say this is the only, you know, clean cases that we can confirm this is a Zeeman triplet. It's not easy, but it can be detected. For example, for this one, you can see the position angle of this, because this is the plot of particular spot in different, it does appear, you know, it doesn't, you know, in several channels. So you can say that, you see, this is the position angle of the sigma plus and sigma minus, and here is the pi, and they are totally about 90%. Plus and minus, if you talk about effect of Faraday rotation or different beaming effect of sigma plus and sigma minus, or LCP and RCP may have suffered the different beaming effect. So just example, this is with Merlin, which is not as high resolution as the VLBA. But later on in 2006, this is an experiment by Fish et al. Fish et al. Observed this sources using VLBA, which is higher resolution than Merlin. But in general, we said Merlin can resolve Maser spot. However, you can see that the Maser spot itself is still, you know, very compact. For this source, for example, with the VLBA resolution, you can still see that this pi and sigma plus and sigma minus component that can be detected. And of course, I think Fish also have some information about that. You can see the position angle here is completely sigma plus and sigma minus is aligned, and the pi component is perpendicular. So this is the extra information that you can only get when you do full polarization observation with the VLBI instrument. So that I just want to highlight this as you know, to answer, I think, or to clarify yesterday's discussion, because we spent quite some time discuss. And also for the southern sources, I think the LBA, I think Gordon showed us. I just want to point out that there's a paper by Chanapot. He was a Thai student, yeah, working on the LBA at that time with Richard. Yeah, we had Richard and Maria helping, and Jimmy as well. And we tried, actually, that was the attempt of trying to do full polarization, but with the LBA, I think the polarization calibration is quite difficult because the different style of the antenna, and someone actually Chanapot himself, he also had a paper on the technical in terms of trying to define the polarization characterization of the LBA. Yeah, with the help with Richard and Maria. So just want to point out to this paper of it's the same source, the NGC 63348. Yeah. So we do have some VLBI map that show very complex. If you remember, I think you all was in his talk yesterday, in Gordon talk yesterday. The mesa is not simple, they are everywhere. And sometimes, it would be ideal if we could find all transition, some cloud that have all transition. And that means that if we have more sources, of OH mesa to study, which or with the, the survey with more Southern Sky survey. So I think we'll be chance to, get more interesting sources that we can study and try to, confirm this theoretical or the physics of the Zeeman splitting itself. Yeah. Just want to highlight. Yeah. So I think back to the VLBI, I think apart from the single dish is, of course, I think is important for the monitoring or study the I would say that, however, if we don't have the VLBI, it's very difficult to say, whether, the Zeeman pair is a real Zeeman pair. That's why I think we, even for Thailand, having a telescope, we would like to participate in VLBI. And I think for mesa size, especially OH mesa, which I think now I'm very happy that it's come back. Because for some time, people move to methanol, and then because I think give you the background of the OH mesa polarization with the L-band polarization. People think that or it's possible that it can be affected by Faraday rotation of the media between and in the L-band. Yeah, this information can be supported from pulsar observation. However, the Faraday rotation can depolarize the linear polarization and become circular. So that's why, I think the community felt that they're not trusting the polarization vector of the L-band, the ground state OH mesa. However, if I remember correctly, there's a latest paper, whether it's Kobach, is G9. Is it G9? If someone remind me, or some methanol. I think Anya was mentioned yesterday. So apparently there's maybe after the end of discussion, I can find this paper show actually the polarization position angle of OH mesa agree very well with the methanol. Yeah. So this will be very interesting if we can do more sources. Yeah. Especially Southern Sky. Yeah. Malcolm, if you want to. And especially I would like to say that we still have Malcolm still in the business. And Malcolm lately he have the code that can generate. Yeah.
Sorry. So yeah. So I mean the Zeeman patterns you show there that they look right. That they've got all these, particularly in the 1720. So you've got the three different pairs.
Yeah.
And I think that sort of explains very well what Gordon was saying. I think and I think originally people assumed with mesas that you just see that inner pair that have got the strongest A value, and now maybe people have modified the idea. I'm not sure who, but maybe there's contribution from all three. So you,
right.
you know,
But the
bigger.
Yeah. But the value that he showed is already adapted 20 years ago. The splitting coefficient of 0.114, I just checked. It's it's not new. Yeah.
That I think is very close to the inner pair.
Yeah, exactly. But I think important thing that I would say that with the survey that we have, right, for the southern sky, maybe we can look for those, you know, those who have more than one line. Yeah, either the complete 3 lines, you know, 3 transition 1665, 1667, and 1720. Yeah, and do further study. Sorry.
Yeah, I say it's a good idea to sort of follow up or sort of copy the monitoring from Parks, and so that would do a good flux calibration. So.
And I hope with the with the universal back-end system, we'll be able to observe full polarization. Yeah.
Yeah.
But of course, we need more manpower. Yeah. That's why I think for TNRT or for NARIT ourselves, we would like, I speak on behalf of NARIT here, that since Thai community is very small, and radio astronomy is very new to Thailand. Now we have facility and we open for collaboration. So we would say we would like to encourage, if you have student or postdoc and interested in this topic, and then we can work together and we can submit a nice size case. Yeah, proposal, at least I think we passed the cherries already, but I think we can submit really good proposal, and then we are happy to host your student or your research team, visiting NARIT. Yeah. We already have MOU, in Thailand, MOU, the memorandum of understanding is quite important. That's the way we can, apply for the budget as well. So I think so far we have the MOU with SRO, which already extended. And I think, Anita, you are in University of Sydney now, and we are welcome. Yeah, any of your institution, even though we're doing a small project, but by having this, official umbrella, so we can, try to find the funding and support, the ongoing project. Yeah. And even in Mexico.
I found this.
Thank you.
This white paper, is it still pretty updated? Sciences with the TNRT?
I would say, well, I mean, I wouldn't say not really, but I think we need to revisit. I think it's time to revisit the white paper, because at that time the outcome of the white paper came out from the workshop again. We invite all the scientists to come, and then we have the telescope and what science can be done, and we have lots of contribution. But now I think it would be nice. I think I also discussed, I think we discussed at NARIT that we were to organize maybe a small workshop. Yeah. For example, lovely, yeah. we can organize a small workshop, focus on, OH Mesa for following this meeting, if you are interested and sign up. I think that may be a good start.
Yeah, schedule it during Southern Hemisphere winter so I can get out of here.
Yeah. Exactly.
Did you mention before the velocity resolution of the telescope? I may have missed that.
Yeah, maybe Bank can, or we have it on the.
It says 0.34 kilometers per second.
Yeah, exactly.
Okay.
which is
So
really good.
yeah,
Well, for me, that's really good. Yeah, Mazers, I think you might need
for
a little bit better than what I need.
Mazers, it's okay. It's okay.
Okay, all right. I
Um,
smooth everything to 1 kilometer a second, so.
yeah, I'm used to 0.1. Very spoiled.
Even OH emission.
Yeah,
There you go, yeah.
for the diffuse OH emission, it's great.
That's
Yeah,
good.
yeah.
I was thinking with some of the maser monitoring stuff, because yeah, the problem that you can get into, of course, if you have too coarse of velocity resolution is if your maser is peaking in different channels, it can kind of, but then we can fit things, we can get past stuff like that. But yeah, I was just having a look at some of the spectra of some of my favorite little objects. Because I have in the parks program, I've identified quite a few that seem to be varying on day timescales, or maybe weekly. I don't know. It's hard to resolve that. But that I think would be super interesting to be able to, potentially get long chunks of time. Is that something that, or are you looking for more small projects?
Right.
Well, so I think the current setup when it comes to proposals is that it's like on a cycle to cycle basis. So even though you have like a long-term project in mind, you might still have to submit another proposal. But then obviously if you've got some form of like results, like even preliminary ones, they should be kind of like included in the proposal so that we know, okay, you've got something that you'd like to really look at, for example.
Yeah, I suppose I wasn't thinking too much of the long term in terms of like, span of like semesters. It was more of I'd like to sit on one of these for 12 hours, that kind of thing. Not because not because I need that sensitivity, but because I'd want to see if it changes in that kind of time frame.
Oh, well, I mean, in that case, that is totally doable with the current kind of operation that we have right now. So I guess I should mention that at the moment we have 13 hours per day, and we have just expanded the operation windows to be basically every day now. So we do it like 7 days a week, just not 24 hours yet, because we still don't have remote operation. It's all done by the operators, unfortunately, for the moment. So it all depends on, how the schedules work and stuff like that. So basically we'll have like a big chunk of 13 hours. So you either have like a day shift or like a night shift. And that also kind of depends on what worked best for that week. So, for example, if you'd like to observe these sources that we know we have to do within this month, then we might set up, okay, this week should be like during daytime. And by daytime, I mean, starting from 9 in the morning, well, yeah, like 9 in the morning until like 10 p.m., something like that. And then, when I say night shift, that is, start from 10 p.m. to like the morning after. So again, like we have these kind of limitations, but if you're talking, okay, if you want 12 hours on the source on a single night, that is totally doable with the current setup that we have.
Cool.
Yeah.
Do you record the whole band? Like, do you just record the whole bandpass? So, because there's no zoom bands.
Pretty much, yeah.
Okay. So you get H1 and OH at the same time?
Yep.
Interesting. Yeah, and then what's the
Do you have anything
beams?
to add? Sorry.
Oh, sorry, the beam size is what? I should be able to do this in my head, but
Roughly 20 arc minutes.
okay. Yeah, that's really good. I used the 20 meter at Green Bank, and that was like almost a degree on the sky, and we still found a lot of OH towards the outer galaxy, which is very exciting. So
So yeah, and I guess I should mention as well that when it comes to monitoring, we are also open to, like you can have, for example, like different time frames that you're interested in. So, you can do like a burst of, I don't know, like daily observations, and then you can do like weekly and monthly, something like that. Because we have one of the proposals that we accepted this cycle that suggested, okay, they would like 6 epochs, but then they would do like slightly different time variations. So, like closer and then a little bit further away. And yeah. So that is also possible.
Let's see. I think the first thing I would try to do is going back to faint OH, where you probably need to observe for like, I don't know, 2 to 5 hours per pointing, is map out sections of a molecular cloud on the local bubble. So just things that are very close to us that already have CO maps, but the idea is the CO dark gas is at the cloud edges. So yeah, 20 arc minutes. I don't know. I would have to find a suitable cloud, maybe Chameleon or, something nearby that has a lot, that's been studied very well. Yeah, I mean, I guess we have plenty of time to write
Yes.
the proposal. I assume it's like what 4 pages, same, yeah.
Yes, I mean, pretty much. I mean, we're a bit more flexible when it comes to the number of pages, but yeah, 4 pages is about right.
The data reduction is not complicated, or is it in development?
So I think Nobuyuki can say about
Yeah.
this.
One limitation is that we can not provide general file format, fits file. We have used the so-called MB fits, originally developed for multi-beam observations, and other observatories have created a converter from MB fits to fits file. That's why ideally we would like to also make a converter for our MB fits to fits file so that everyone can analyze our TNRT data using world standard software such as Gildas class or something like that. But now we have developed our own Python script to analyze single dish spectroscopy data. So it's not so much complicated. Just general procedures are applied based on the Python. So not so complicated.
That's great, yeah. And have there been, sorry if this is already mentioned, like any published spectra we could look at?
What do you mean? Sorry. Could you say again?
Like can we see some examples of some OH spectra from the telescope? Or
Yeah. We have conducted science verification, and yeah, we observed the same source at different telescopes simultaneously to check our flux calibration and velocity calibration and so on. But on our web page, we have shown our H1 spectrum. Just a moment.
yeah, I'm sorry, I missed the talk at the last or the late session yesterday. Maybe this is already covered.
Yeah, this shows our H1 spectrum, and we compared this with other results obtained by FSberg, LAB, and GAS survey. So maybe Parks and the Dwinglow and FSberg. Yes. and we confirmed our amplitude scaling and velocity scaling are consistent with other telescopes within a few %. Yeah.
There also 1720, right? The comet, OH measure from comet.
Yeah. We have obtained a lot of spectra of OH for transitions using the telescope. So yeah, we can say that we are very confident to do OH observations. Yeah, that's why I was asked by NARIT College to attend this workshop so that I can learn OH science cases. Yeah, thank you very much, organizers, for hosting this workshop this week. And yeah, as already mentioned by Busaba, we are always happy to collaborate with any of us since we are now developing many items. So if you are interested in some of commissioning items such as stocks or anyway, anything, maybe if we have a good agreement or some collaboration idea, yeah, NARIT would be happy to welcome you or your students or your postdocs to NARIT. So yeah, thank you again for this great opportunity this week.
No worries. Thank you for coming.
Yeah, thank you for showing us this awesome telescope. Yeah. And I've always wanted to go to Thailand, so.
Very welcome. Also, I think when I would like to add one possibility as well, despite that you're not based in Thailand, if you have some idea, you know, of follow up some small project, you know, it would be good if we could set up a few, you know, small project that can be done by Thai student. You know, we have a lots of physics student or astronomy student, but they might not have enough knowledge in radio astronomy. But if we can set up some, you know, maybe just some simple project that you could also co-supervise, I think that will help us a lot, because so far we had you know, the scientists at NARIT. I think we have Bang, we have Nobuyuki, but we are happy to be you know, help with the instrumentation, but in terms of help to guide the student in terms of scientific or for the project. I think we're very welcome. If you can say, oh, I have this part of small project that, you know, can be done with or can be tested with TNRT, and happy to help to supervise, because now we have online, you know, and communication, and may not consume so much of your time, and we can advertise that. I think that would be quite a good, you know, approach to Thai community or even Southeast Asia student. So we have annual meeting of Southeast Asia astronomy meeting every year, where other astronomy institute also attend. And if you have some idea or project and need people to do it, and, you know, just feel free. We can help to advertise and maybe set up the meeting. Yeah.
I have lots of ideas.
I was gonna say,
That's
yeah.
good.
Anita has lots of need for students. Actually, I mean, I think we all have needs for students. So much data.
Particularly with new observations. Because yeah, like I said, I've got a lot of pet masers that do weird things, and yeah, if it's possible to get, you know, a couple of long tracks on this that a student could then, because that's always my problem, right? I have all these ideas, but I don't have the time. But I think that would be such a fantastic opportunity for, you know, for the Thai students to use their telescope, of course, because I mean, I'd love to just take it away with me, but no, that's awesome. I'll send you some details about some ideas I've got. Oh, but Allison, you got your hand up.
Thank you. And I don't know if you've already mentioned this, but are you planning to have anything like a training workshop? Because I don't know if you've been in a single dish workshop from Arecibo and Green Bank and other observatories. Maybe, you know, you are familiar with that, but it was a wonderful way for us to train people to use the telescope. So sorry if you mentioned it already, but that was, you know, there are lectures about how does all of this work and setting it up and submitting proposals, and then hands-on projects for for researchers and students. And that was really a nice forum. And you can have it. I actually had to do this at Arecibo during the COVID era because people couldn't come to the observatory. We had a worldwide virtual single dish workshop, which was wild to coordinate, but it was fun and it worked. So maybe you could do the same thing. And if you haven't been to one of the single dish workshops, I know that Green Bank will probably have one in August or so. So it could be a good time to see how did they run it and repeat that and train people to use the telescope would be awesome. I would do it.
Thank you. Yeah, but thank you. That's really, I also have in mind that I think we need to organize the winter school or summer school.
Yeah.
Yeah, to start with. Yeah. And then we can invite all of you to, to give a talk and, help teaching in a little bit of, essence of radio astronomy. Yeah. Either on site. I think we'll be really happy for invite you all to on site.
That would be even better.
That'd be great. Anytime.
Exactly. Yeah. Suddenly we have a bunch of people already. Yeah. Focus on just single dish with single dish with OH, Anita.
I keep telling people it's way easier than interferometry.
Yes.
VLBI as well. I think VLBI is still, interferometry also very important. Yeah.
That's very important. Yeah. Shinji, do you have hand raised? Yeah.
Oh yeah, I commented after Sakai-san talk yesterday about the asteroid observation, but let me reiterate to follow this up. Yeah, so I'm based at Canberra Deep Space Tivimbira Station, and we have a 70-meter dish, and we recently installed L1 receiver. So yeah, so through ATNF, we call for proposal every 6 months, and next deadline will be end of middle of December. So we welcome any proposals to use our relevant capability, or we have also 22 GHz K-band receivers, which works from 17 to 27 GHz, yeah, about 10 GHz wide, yeah. Which is the largest stable telescope in Southern Hemisphere. Yeah. So yeah, we welcome those proposals as well. Yeah. And also, I'm commented about bistatic radar. So we are part of a NASA Deep Space Network. So we have a 70 kilowatt transmitter, which is primarily for space communications, but we use that for also bistatic radar to observe asteroids. And we transmit that at 7 gigahertz, but we don't have a receiver. So we've been using ATCA, and also we can use any ground-based antenna that can receive 7 gigahertz. And so the new telescope in Thailand, so you're going to get a C-band receiver, so that will be capable to receive our transmitter frequency. So we wish to collaborate for bistatic radar as well. Yeah. And the big event I'd like to draw your attention is that in 2029 April, there will be asteroids flyby asteroids named Apophis. So that will be passing within 4-5 Earth diameter. And there will be big campaign to observe this asteroid. And I think United Nations will nominate that 2029 as International Awareness of, sorry, I forgot the exact name, but yeah, asteroids and planetary defense type year.
Oh, wow.
Yeah, so I bet there will be a big campaign, and we are also planning bistatic radar. The Apophis asteroid will be approaching from Southern Hemisphere, passing above Australia and the Indian Ocean, then center of Africa, then somewhere in Atlantic Ocean that will be nearest point, and going through north. So it's coming back from Earth and passing again, I think somewhere Eastern Asia, yeah. So you'll be very good positions to observe this from Asia. So yeah, that will be another opportunity to receive our static radar signal as well. And you have an optical telescope, so you'll be very much capable to follow this up. Yeah. So that's something I'd like you to be aware of this for upcoming project. Yeah. Anyway, that's my comment.
Yep. Thank you very much.
Yeah, thanks, Michael, for the link for the telescope.
Oh yes,
Yeah,
I'll put them in the Slack too,
Yeah.
because I just submitted something for Parks like a couple weeks ago, but
Okay. Yeah.
yeah. So for the next proposal call, will the 70-meter it will have L band, right? Able to observe OH, but it's only sorry, I saw somewhere on one of these links. How much time is available per observing semester?
Yeah, so for 70-meter, it's typically like 5% of total operation time. I mean, measure. Yeah, so it's like a couple of times a week for like 6-7 hours each. Yeah, something like that. Yeah, typically. Yeah, I mean,
Okay.
yeah.
So I may not be able to get my long integrations, but that's
Yeah,
okay.
not very long, but
Not
it's so it's I think the 70-meter is suited for survey type project. Yeah, and we can also do on the fly mapping. Yeah. But yeah, we just got a new backend, and we need to set up lots of stuff like software and yeah, pipeline. Yeah. Yeah, for the time frame, so yeah, next call for proposal is in December, and that will be for semester starting from April next year. Yeah. And ATNF proposal is usually for 6 months, but for LBA and TWINBILA single dish, it's active for 12 months. Yeah. So for next deadline, yeah, you will propose for next 12 months. Yeah. That's good for LBA and TWINBILA project. Yeah. You don't have to update every 6 months, but yeah, every 12 months.
That's very cool. That's very nice to know. Anita, I noticed you posted some stuff in the Slack. Do you want to chat about it?
That's my idea for a student project. No, I've got I mean I can share. I just did a bunch of screenshots, so I can share. Maybe. Hold on. Maybe. I don't know if I can share with like preview or if it's gonna get angry at me. It's better than me scrolling through the paper from which I found it. So hold on. Finder, yeah. So this is G330. There's quite a lot of masers at 1665. So this is a group of them, and then there's another group. Oh no, that's not it. There's another group at around sort of 60, so it's probably two different spiral arms, or at least two different distinct areas here. But it's a shame it doesn't zoom very nicely. That one that's close to -90, all those points that like all the dots there are peaks from different spectra. So this is like 2 years worth of spectra all overlaid onto each other. And you can see that the peak of that maser changes a lot, but the pattern is just wacky. I've observed this one on shorter time scales. Like I had a campaign where I was looking at it twice a day for a couple of days. I still can't really see any pattern in this, but it jumps around so much. I have no idea what's going on there. If you look at the behavior of the flux of the other masers, they're relatively constant. They kind of vary with one another. There's some variability in there, but nothing like that one feature. There's also features in, where are we? In 1667 at similar velocities. So they might be associated. They probably are associated. And again, they don't have anything approaching that weird behavior. This is the closest one to that wacky one in 1667, so it's not doing the same thing. So, and again, the other ones in the sort of 60 kilometers per second aren't, they're varying a lot, but nothing is as strange as that. So yeah, I want to know what's going on there. I'd love to update this with more recent data to see if this is just a period of weirdness or what's going on there. But that would be a cool project for a student, because if they took some observations even throughout a week, they might be able to see some variation within a week, and that's satisfying for students, I reckon. But yeah, that's just my idea.
I follow up on that because it's actually was the same source that I work on with Jim Caswell. So maybe I can share you how the mesa look like. Yeah.
Okay.
So this is the observation, I think is back in, because at that time it was the source that he selected is a good candidate that we should map. So that was 2000, was that when it was observed? I think it's about 2000, is it? Yeah, 2016 August in 2000. So if you have some data back then, so the 1665 and 1667, you know, it's everywhere. It's very rich. Yeah, left and right. And I think he really, you know, with the single dish, right? You already expect that this probably could be a Zeeman pair, right? And when you map it, you know, with the LBA, this is with the LBA, okay, the resolution may not, maybe a little bit less than the VLBA, but however is enough to locate the, you know, the cluster of mesa. So really, it would be really great if we can do a couple of epochs, you know, and it's matched with the variability, and then you will see which mesa is actually flat, whether it's the same, if it happened at the same, you know, particular, you know, position, mean that area is really active, is the one who actually, you know, create this variability. So this certainly needs to be a good sources, even though without TNRT joining even the LBA itself, I think you need to create
Sorry, did you confirm that as a Zeeman pair?
Oh yeah. Here we mapped it. Well, I have to go back to the paper again. That was some times ago. I think we could identify whether some, I think some are really, but some are multiple spot. It's not 100% because if maybe I'm wrong. The problem when you do VLBI, you have to do self-calibration, and sometimes on the strongest channel. And the problem with the strongest channel, sometimes it's not just one mesa. Sometimes you have multiple mesa in the same particular channel. So that will contribute to the highest peak, you know, very bright peak in that channel, because you have so many mesa in the same, you know, at the same frequency, basically.
I noticed you got there are several Zeeman pairs in the table.
Yeah, certainly. Yeah. But I think I have to go back and check whether it actually confirmed. Yeah. But certainly you can see this is the way we plot the, you know, the IA distribution of different velocity to, but I think the main idea is to see where it's actually flattening. So I think you need a couple of epochs, because this is just the observation of one epoch. Maybe that's a good for LBA proposal together with TNRT parks monitoring. So that's a good source, for example, which, you know, sometimes people not pay attention on it, you know, because okay, Zeeman pair and so what. But nowadays, can I go back? Since I'm here, I want to show you again. I loaded, maybe I stopped sharing at the moment. I just want to, I found a paper that I want to show you. And this also, you know, could bring OH, well, sorry. I share, but Why don't we go to that window? Somehow doesn't go to that particular window. Oh. Yeah, this one. So this is the paper by, okay, yeah, Daolio, yeah, on the source. I think it's very beautiful paper of the star forming region, very, very complex. And then here, you know, you see like jet and, you know, some kind of core, hot core. And you can see, they also have ALMA, I think, and different, you know, cloud core, hot core. And values, and with the dust, you know, polarization, you can identify the magnetic field. Yeah. But it could be different, you know, how you say that, different scale of the magnetic field, because where you find maser, you actually found maser deep inside. Malcolm probably can tell us more about this later. For example, for this particular clump, they actually see the dust polarization trace or this jet, you know, what if you know about the jet polarization, so magnetic fields really trace the jet structure. And importantly, this is the dust from ALMA, dust polarization from ALMA observation and OH maser. You see how if people say that, you know, OH maser ground states suffer, polarization suffer from Faraday rotation, you cannot trust the how say that, the projected or the polarization position angle. But how come if it suffers so much from Faraday rotation? Because the theory said if it, you know, if it affect, so it can rotate your vector completely. For example, if you have sigma plus and sigma minus travel together, and then one can affect more, so can be like tangle. However, with this source, it's evident that somehow the polarization of the OH maser preserved, because it's agree very well. Of course, in some cases not agree, but most of the cases agree very, very well with the dust polarization. So I think this is very good news that bring, you know, full polarization observation back to OH maser again, and can help, you know, really study the Zeeman pair. Yeah. So I put the link of this paper. Yeah. It's always come back to the Zeeman pair, whatever I talk about, some reason. Yeah. So. So certainly I can add, you know, following Anita's suggestion, I will also help to put more information down, and I think we should certainly submit the proposal to TNRT for this monitoring. Yeah. And maybe we can work on, you know, later with the LBA. Yeah.
Yeah, very good idea. Yep.
Yeah. Anything else? Yep. Anything else from the late type star or edge? The Lucero.
I have some weird data on that too.
Yeah. Maybe we should think of a nice project for the late type star. Just observe the OH maser.
OH masers. Yes, I've been thinking, but I don't have any idea in my mind now. But I think we may work together. Maybe we collaborate with Hiroshi in mind. I don't know if he has something in mind.
Yeah.
One idea about 1612 megahertz OH maser is to monitor the so important OHR stars whose distance should be determined using the phase lag between the red-shifted and blue-shifted components, and the time lag corresponds to the linear distance of the shell. So using the interferometer to determine the angular size of the envelope, so you can determine the distance. But there are so many OHR stars, so it is crucial to determine which source should be monitored for a long time. But yeah, one of them is so some of them should be in the solar neighborhoods, but maybe I'm interested in the, for example, galactic bulge and the central galactic center and so on. Yeah, also the envelope cannot be especially distinguished solved at the for the envelope at the 8 kiloparsecs from the sun. So it is still important to explore the how to say the star formation history, which generated the cluster of the OHR stars. But this is just my idea, but maybe we can find some other idea as well. Yeah.
Yep. So I think I know from the phase lag, I think Dieter and also Sandra, right? Working on this as well, right?
Sandra definitely knows how to do this and like calculate some distances in the past.
I think I've seen they've been using Ephersberg as well, right?
Right.
But TNRT should be enough, should have enough.
But there are limited number of the target sources, I think.
Right, okay, yeah. But the sensitivity should be enough for the 40 meters, should be able to do it as well.
Yeah, I think so. I think so. So actually, you can see some paper published in 1985 and so on. Some of them monitor for example, the water fountain sources, which determines the pulsation period of the central star.
So I think we can, from this discussion, I think we should organize certainly a workshop in Chiang Mai, focus on OH, young and old, and the fields, of course.
You can make it about 3 months long. That'd be great.
Yeah.
Thank you. Yeah.
So I think we will try to propose that. I think, yeah, that would be really cool. Yeah. And organize the school at the same time. Yeah.
I'm thinking now of the projects. What is the best way? So I imagine the students that come from a nearby university, is it like Chiang Mai University or something?
Well, there's Chiang Mai University as well as in Bangkok. And I think we have to write the case and apply, because we at NARIT we also host we call international the UNESCO international training. So therefore we do have budget to invite a student, even I think I'm not sure whether they pay for the airfare, but in Southeast Asia. Because I think I know we had quite a good number of students in Indonesia, Malaysia, Vietnam also, yeah. So I think in terms of spectral light, I think and encourage, stimulate the uses of the L-band receiver. I think at least for our community, I think if we have a good, a bunch of students working on it, that would be really great. Yeah.
If we wanted to advertise a project to a student, should we just write, like a PDF, and who do we send it to? Is it you, or is it Nobuyuki?
Yeah, please welcome to send to Nobuyuki. Yep.
Okay.
Or anyway, one of us is fine. I think we try to put it somewhere and together. And we could set up we could set up a web page or somewhere that you all, interested to be part of it. Yeah, contribute and offer the project. Yeah, and contact. I think that can be. I think we could do the form to sign up maybe. Or following this workshop would be good. And then we try to publish them on one of the TNRO website. I think we can advertise there as well, together with the call. We can have this is potential, key project that, looking for student. I think that would be a good idea. And then we'll ask of you that, to send us description and contact, and yeah. At the same time, we try to provide the support as well. for the student. Because I think in Thailand or in Asia, I think hand-on, experiment, still be quite good compared with just get the data and work on it remotely. Yeah. In the past, we used to host also Sokendai. I think the Japanese, right, in AOJ, or that can be the school that can be, apply for funding and can be host in the topic of the interest. Yeah.
I remember there was the joint winter school, right? That was a few years ago.
Exactly, on the topic. And if you're happy on that, on be on board, we get you signed up and become the SOC and lecturer, whether online or on site. Yep. I think in terms of Anita, in terms of organizer, I think, are you very happy of the outcome?
Yeah, I must say.
At least on the discussion. Yep.
Yeah. I've been super happy. Yeah, I tell you, it was funny watching the registrations come in. I kept every time I was meeting with Michael, I'm like, guess what they're up to now? I was fully expecting 20 people to come, and there were 70 people registered. So it's
I was expecting 20 people if we were lucky.
yeah.
The way you organize also very amazing. It's not easy. It's totally complicated. I'm also new to this, even to participate, but it's wonderful.
I'm glad it looks like that, because it didn't seem to be too bad. Because like, I don't know if you noticed, but pretty much everybody who said that they were willing to do a talk did a talk, and I just sort of organized it around that.
We will copy. We certainly use your idea of organizing this, because I actually talked to the other Anita. Welcome, know her very well. The Anita Richard and Sandra Itoka from UK, and they all said, "Oh no, I can't do this out. Please give me a break. Out with Australia." They're too old to do that. But I think being joy partly and then can go back to see how, presentation and follow up, I think is very good. Yeah.
Yeah, I'm really happy how it turned out. This has been really cool.
We might have to keep organizing it. Yeah. Okay.
On the topic of doing a workshop in Chiang Mai at Narit, and also doing like a school, like a radio school kind of thing. I think that would be like, you aware of the ATNF radio school?
No. Well, I used to hear about it, but when is again? Usually it's host.
I don't know. Since COVID, it seems to have kind of sputtered a bit, but I think that they're planning on doing one this year. I think it may have already, I don't know. I'm not really plugged into that anymore. But that just as kind of a model of how to do things was really cool. I only did it 1 year. But I think they often host it in Marsfield at CSIRO, but then the year that I did it, it was in Geraldton in Western Australia. So we got to go on a day-long field trip to go visit the ASCAP, which was super cool. But just as a general model though, I thought that was a really fantastic thing, because it's an opportunity to get a bunch of students together and really get I think is it Rick Purley from VLA, who every year he does this amazing presentation on interferometry, and I swear it was the first time that interferometry really started making sense for me. So yeah, I mean, it's a really good talk. He has the same slides that he's been using for like 20 years, but they're good slides. He has, I think, a couple of sessions that he did, but then we also got to play with some data on the POSI supercomputer and all that. But yeah, I would be more than happy to help out with something like that if it would be helpful. And I've got some workshops that I've already made on things like applying Bayesian statistics to Gaussian decomposition and that kind of thing.
Right.
Yeah, because we also have the Harleywood school that we run, which is the couple of days that are before the ASA meeting, which is, what is that acronym? Astronomical Society of Australia, I think it's called. So that's, yeah, another thing that has a similar kind of model of getting a bunch of students together and forcing some astronomy down their throats, or radio astronomy when we can, which is great. Yeah.
I think we really will take it, and then probably will update you all later when the time scale, certainly because Thai fiscal budget year start in October. So I think probably between now to October, we probably can't organize anything, but until, next year at some point, I think at least we need to apply. So we could, in Zero Model, I see that they can even give the candidate, since we're going to pay for their trip, we really have to select them. Either we give them the task to do, and they have to submit the task, and then we select them. Those who be selected, we'll have a project that can be on. Maybe that probably more, how to say that, more concrete. Often we organize the school, and students come and listen to the talk, and then they disappear. That's the problem we have in Southeast Asia. We might have, I don't know, I think we have less than 10% in radio astronomy, probably 1%, I don't know. Yeah. So if we might, maybe we probably try to work out the model, what would be the good impact, especially if you all, propose some project and, some we say that scope of work, and then we do some like pre-organized before the school. You said you are interested, and I think we really have to set a criteria for the student, that they really be the one who want to have a project for their undergrad or for master. Yeah.
And I think it's a really good thing to do to, when you're able to have that kind of influence on the students, where you can kind of dangle a carrot in front of them. It's like, we'll fly you out here if you do a project with our telescope. That's awesome, because I know we all probably feel the same. Whichever telescopes you used during your master's and your PhD, that gets kind of baked in, and those are the ones that you want to use forevermore. So that'll be a great way to build your user base for the new telescope.
Great. Totally agree. Yeah.
Sounds great. I'm excited.
Right. When should I book my flights?
I know, right?
So January is good, or maybe May or June are better? Normally, I mean, are you all teaching as well?
I am.
So when is the term break? That when if you can come for a week or something?
Yeah.
It would be a good time.
June, July is good. January is a bit tough because there's usually other, with Christmas and all of that, there's usually other travel.
Get together, isn't it?
Yeah. Yeah. Because it's definitely uni holidays, but other stuff. Would the weather be prohibitive there? Like, would it end up getting too hot where people wouldn't have a very good time, or?
It won't be hot, but would be raining.
That also
Raining's fine.
On
Yeah,
July
but it's
is
not raining every day.
Yeah.
On
It
July
doesn't rain all
rain.
day. It doesn't rain every day.
Yeah, and unless we have a monsoon coming, that would be some bad luck. You could have a rainy day.
Yeah.
But in general, it's cooler. My father is quite cool. Cool means 24, 25 degrees at night.
That's lovely. Lovely. Yeah.
But the good thing in Thailand, we can organize this in hotel. They're very well organized. Yeah. Provide lunch, everything. Yeah. And we all cold sitting in the air-conditioned room.
Sounds very nice.
Yep.
We have opposite effect of being cold.
Oh, yeah.
Okay. But if you really want a nice
TNRT.
weather, you have to come in November or December or January, as you said. Yeah, that would be the dry season and a bit cooler and less humid. Yeah.
Well, I'm still on postdoc fellowship, so I don't have to teach. So, but January is AAS, I think, is in the first week, maybe. But anyway, I wanted to thank everybody for a great conference. It's 9:30 at night for me, so I think I'm gonna head out.
Yeah. Thank you, Anita, again, and thank you, everyone.
Thank you.
Thank you.
Participating. Yeah.
No worries.
And we'll be in touch.
Yes,
Thank you,
please.
Anita. It's been great.
Thank you.
Oh, no worries. Thanks, Malcolm.
Yep. Thank you, Malcolm. See you.
Thank
Yeah.
you very much. It's nice to see you.
Bye-bye.
Nice to meet
Hope to
everyone.
see you again.
Thank
in Chiang
you.
Mai.
Yes.
Yeah.
Yeah.
Bye.
Bye.
Oh, didn't want to kill the discussion, but I'm falling asleep. I didn't mean to. It was sound like everyone was pretty much done with discussing, but
Yeah. There was a time there when I noticed like everybody was muted.
yeah, I was like, oh no, I need to ask more questions. But I wrote down a bunch of notes about Thailand in January. I got to get them interested in diffuse OH.
Yeah.
Oh,
Look,
he's amazing.
what time I think I went in May. And
How was it?
I was there for 2 weeks in May, like a year, and like not this May, but like a year ago. It was amazing. Absolutely
Wow.
amazing.
Oh my
So I
gosh.
stayed in Chiang Mai in the there's like the old city, and
I've
it's
heard only
just
good things about it, Chiang Mai. Yeah.
you just get out of the hotel, turn left and there's a temple, turn right, there's another temple, down there there's another temple.
Wow.
And like really fabulous temples. It's not even like
Mm.
little thing that no, there was that too. There was the ones where it was like, the corner right by the stoplight, there was a little temple, but it's just temples, and it's just so cool. Yeah, we rented